mechanical power. So how, what is the basic thing? So like a power. So the symbol is what we usually use, like a P, that one. So first we'll go for the average power. So this is like a work done by time taken. So what is this average power? Like how we used to denote, no? P average, V average, P average. This will be work done by time taken, or delta T, you write it. When it comes the applications, the average power is very important. Instantaneous velocity is important. Average velocity may not be that important. But when it comes to the application, average power is important. Instantaneous power is of no use. Of course, we do discuss numericals, but when it comes to application, no, the instantaneous power, at that instant, what is the power dissipated? May not be useful. Average power is what matters. A good example, the electrical power. So there, the electric meter, what it reads, average power or instant power? Average power, no? At that instant, so what is the power consumed by all the electrical equipments is what instant power. Over a 1 month, what is the energy consumed? Energy over a 1 month, energy consumed by time taken. That will be the average power. So you take any machines, everything, no? The average power matters a lot. So we'll take some problems like how to calculate average power also. Then what is the necessity of the power has come? So whenever it machines come, no? Especially you see the water pump. So 1 HP motor, 2 HP motor. What is 1 HP? What is our 1 horsepower, that one? Since we need larger units, if you go for some machines, no, 1000 watt, 2000 watt will be the power of the machines. So to express that in smaller quantity, the horse is brought here. 1 horsepower, 746 watt. There's the only difference here. So if you look at the water pump, no, we express in terms of 1 HP, 2 HP, 3 HP, 5 HP. 1 horsepower. It's defined like this. Then the what is the necessity of power has come? Already we have work done and energy. Why this power has come? So let's take one. So let me take the situation. So there is a person is there. So he has to, he will climb steps and he has to place them a bricks, each of how much? Say like a 1 kg. Like that there are 5 bricks are there. Similarly, another person, okay, there is a person A, there is a person B. The same steps, the height of the stem, everything. Rough diagram I'm giving. So this is the height. So let it be say like a 6 meter. Will neglect the weight of its own weight, will neglect. Let's not bother the effect. Only the weight of the bricks will take it. So here again, these are the 5 bricks are there where mass of the bricks is 1 kg. Then what is the work done by the both the persons to place all that 5 kg bricks at height 6 meter? So then what is the work done? We do that like this, no, 5 into mgh. I'm asking you to neglect the effect of his own weight. So this should be equal to mass of the each brick is 1. So 5 into mass of each brick is 1 kg. 5 into 10 into 6. So this will be 5 6 30, 300 joules of work he'll do. What about the work done by the other person? He will also does same work, no? To see the person B also, I'll allow the work, but when he also does the same work in the and he'll spend how much of energy he has to spend? 300 joules here. Neglect effect of weight of person. We are just neglecting the weight of person. Then the first person, let him take a time. Let him take a time, say like around 5 minutes. you will take it, and this person you will take 2 minutes. So then can we analyze what about the power here? Average power of the first person should be WA by TA. So this will be 300 by 5 minutes. So 5 into 60. So shall we put this equal to 1 watt? And what is the average power of this person? WB by delta TB, 300 by 2 into 60. So 2.5 watt. Okay, now, okay, like who is having more power? The person B, no, is doing the same work in less time. So each side to have more power. So here for machine, is it work done by machine important or work done per unit time will become important for machine? Work done per unit time. So that's why if you go for civil construction, the labors, the power of labors matters a lot. You can't just pick up any labor here. So you definitely open the young people will be preferred. Any reason for young people? In a given time, they do more work. Suppose like this labor, what happen? You will charge per day 800 rupees. You will also charge per day 800 rupees. So tell me like from which labor B, what happen in a given day will do more work, no? That's why you see the civil contractors, no? They are very intelligent. They will look at even the person's personality also when picking up the labor for this physical work. It's not that easy job. I'm telling this one. If you become civil engineer, no, you'll come to know that one. How to manage labor, how to take work. It's all very scientific things are involved here. And something which are where more energy has to be spent. There what happens, they will appoint the laborers who are physically strong, where the less amount of energy has to be spent. So there what happens, they will appoint the ladies or some little bit old persons, more than 40 years. So that's why the labor who are aged from 18 to for less than 35, they'll demand more money. So like that what happens when you construct any, go for civil constructions, no, all these matters here. This one, it's not that easy job. You have to manage all these things. The calculations should be done thoroughly of all this one. On and average, this person, how much of work you'll do and how much we have to pay. All this science is involved in that. So similarly, if the machine comes, even the machine also, no. So definitely you can say if suppose instead of person, let there be a machine. I think the machine B is better. In a less time, it did work. So definitely it must have more power. So what type of machines we prefer? The one which will give more power. More power in the sense what happen in a given time it does more work. So what is 1 HP motor? 5 HP motor. 5 HP motor does more work in a given time. So that's why it is able to pump out more water. So depending upon the size of the tank, no, that particular, so you can say that like a power of the machines, what happen, the engines will be preferred here. So there's one basic idea that one. So here, than work done. So what has become now very important? The power, no, the power, that one. So you look at the where all we use, especially in the running 100-meter race. So where the power becomes very important, no, not the energy. So in that 10 seconds or 9 seconds, how much more you are able to do work. Based on that what happen, you'll have power. Based on that what happen, you'll have more running speed. So when you go for the biomechanics, no, there, so some of these sports, what happen, the power of an athlete matters a lot rather than what happen, the energy. So how much of power is able to generate matters a lot. Everyone is energetic, but who will generate power? You will win match. So like this, what happen? All things are involved here. So in advance, they may ask you very generalized questions of this kind. Very generalized questions also this kind, and some physics related and some maths related. So three ways they'll be asking you numerical. So you should be careful enough with these things. What should be the, I put watt, watt, that one, W-A-T-T, watt, that will be power, and joule per second, 1 watt or the unit. Joule per second or watt. Okay, I'll write it here. 1 watt or 1 joule